So let's begin. Here we have our input mesh, as it will be seen by Houdini once ingested via the Houdini engine using the Unreal plugin. The first thing that we need to do is convert this into a VDB, and we could do that using the VDB from polygons node. If you right click and search VDB, you can see a list of all the VDB operations. I'm going to wire this into the left pin, and we can have a look at the output immediately. We don't want to stay in VDB land too long, so I'm immediately going to put down a VDB convert, and we're going to convert this back to polygons. And we can see now that what we're getting is the original mesh as polygons again, but it's different. What's changed? Well, if we turn on smooth wire shading, then we can see that after the VDB conversion step, we have evenly spaced polygons in a kind of grid arrangement, whereas before we had whatever kind of geometry was passed into the tool. The VDB from polygons is detecting where is inside the mesh and where is outside of the mesh, and it's creating this sort of sealed volume, an SDF. The convert VDB is then taking that and figuring out how to meshify it, which is what gives us the result we see here. The goal of this step is to have even topology across the mesh, which will make it work better for the other stages of processing later on. And as a free bonus, you can see that when we turn on smooth shading, we now have a kind of beveling that's kind of appearing just by doing this conversion step. The size of the bevels is going to be dependent upon the voxel resolution or the volume resolution. And I think currently we've softened everything out too much. So I'm going to go back to VDB from polygons, and we can just go ahead and maybe half the resolution. This is now better preserving the original shape, but it's introducing some sort of nice kind of like lighting glints and specular highlights, which we want to keep because this is an organic object that's been operated on by the world, and it has no 90-degree angles. Next up, we're going to perform the fracturing. So the fracturing idea is quite simple. We're going to scatter some points across this surface, maybe just 3. They're a little bit hard to see, so I'm going to turn on the point preview display. And if you're wondering how I keep flicking between this minimal and expanded view in Houdini, I'm pressing Ctrl, Alt, and S on the keyboard. You can find the same setting up at the Edit toolbar, where you can say Toggle Stow Bars, which will remind you what the tooltip is as well, what the hotkey is, sorry. Okay, so we've scattered some points on the geometry, but how's this helping us? Well, there's another node in Houdini called the voronoi fracture node, which we already used, which you will have already used if you did the cliff creation tutorial series. If not, what the voronoi fracture node allows us to do is to split this incoming geometry up according to the points that have been input. And you can see that we are indeed getting these kind of fracture lines across the mesh. They're a little hard to see, and if you looked at this with smooth shading rather than smooth wire shading, then you wouldn't have been able to see them. To help you out while you're developing, what you can do is you can just put down a little smooth operation after the fracture, and you'll see that this is now visible. What I like to do is use the poly reduce rather than the smooth. If I put the percent quite low, maybe even lower still, and then equalize the lengths, we're going to see that, yes, it makes the whole shape look a little bit wobbly, but it gives a very pleasing kind of planar breakup look to these cracks. And we can just play with the reduction amount and the equalized lengths amount to create different kinds of cracks with variable width, which I think looks quite nice.